How's it going, Nicholas?
Good to be on the podcast.
It's great to have you here on the Telnyx Low-Latency Club Podcast. So to get things rolling with us, you are Equinix's, global principal technologist for America's West. Is that right? Can you tell us a bit about, what you've been doing over at Equinix?
Yes, I'm a global principal technologist. I help some of our largest customers with how to use our platform to get business outcomes. It's probably worth mentioning who Equinix are.
Yes.
Typically, people confuse us either with a gym or with a car. But Equinix is one of the largest data center providers in the world. We're in most countries around the world and most metros around the world. We've been around for about 25 years now, and our raison d'etre was originally connecting network service providers together so that they could peer traffic between each other, which is the start of the internet. So fast forward 25 years, we're a massive, large company around the world. About 95% of the world's internet traffic transits one of our data centers at some point in its existence. So I think the best description I ever gave my teenage children of what I do is that I'm an internet plumber.
Yeah. That is a great analogy for the work that you actually do and the work that Equinix does. I mean, they've been an amazing partner for us. All of our POPs that we talk about that are spread across the globe are via Equinix. And whenever someone is like, oh, well, hey, can you guys do private interconnection to us? We're like, you co-locate with Equinix? Yeah, is there another peering point we can get through to you via Equinix? And, so far to say, I mean, pretty much been able to get everywhere.
Yep. So pretty much every country in the world except Russia and New Zealand these days.
New Zealand?
Yeah, I mean, we're from a interconnection and network service provider perspective, a lot of what's very important around the world is the submarine fiber optic cables.
Yeah.
And typically where they land and where they leave most geographies is one of the reasons that Equinix exists for those submarine cable landing stations. New Zealand's a bit of a transit on the Pacific.
Oh.
There's only about 2 million people in the country, so kind of cables go from Sydney to Auckland and then from Auckland up. There's also other routes that go up and around through the Pacific Islands. Okay. It's quite an interesting thing. If you ever look at submarinecable.org, there's a map of all the submarine cables in the world. It's very interesting to see the routes that traffic takes, particularly the pinches in the Red Sea when you get cable cuts. Australia becomes quite important because there's a route now that exists from the US West Coast through down to Australia, across the bottom of Australia and back up. So you have an alternate route to the very constrained route through the straits there near Singapore. And most of the world's data really does go through fiber optic cables. Despite the amount of satellites we've currently launched, as satellite traffic is a small proportion of the world's internet traffic.
And the latency over satellite traffic obviously is nowhere near what it is over fiber optic.
Yep, that's the thing. Everyone forgets about latency and talks about bandwidth. But if you've ever had to run a video call from a satellite phone in the middle of the desert, you'll understand what latency really means.
Like, it works. Like, does it work? Yeah, it works, but like not well enough for real-time communications and to have like a conversation that is going to be somewhat understandable and helpful for both those parties involved.
Yeah, I mean, I've written a few things about this sort of stuff, particularly around the use of internet versus private interconnection for delivering outcomes for business applications, whether that's voice, like what you do yourselves, but also for interactive applications. And now in the world of AI and AI agents, latency is going to be another factor that gates how fast your artificial intelligence systems will respond and act.
I'm glad you brought that up because that's our first topic for today, which is private versus public connectivity and interconnection. And as you've hinted in our conversation, and also as you've written, public internet works until it doesn't, right? And so, can you expound on that a bit more for myself and for our other listeners?
So that concept of the internet working right up until it doesn't is probably the most salient point that you can talk about from a connectivity perspective. What we really mean there is that the internet is good and it's cheap, but it's not particularly reliable and it's certainly not observable. So depending on the workload that you're deploying and the business outcome that you need, it's going to work for a while until you reach a point where traffic is high enough, or you need certainty of latency, or you need specific considerable bandwidth. All of these things start to add up, and to the point we start to realize that transiting things over the internet isn't as great as doing it on a private interconnection. And a worked customer example of this is one of my customers who had production databases in Amazon and their development systems in Oracle for various reasons. And they were transferring data from their production system to their development system every day so that their developers had a refreshed set of production data to do development on. And that process was fine. A couple of big 40-gate firewalls, IPsec tunnels, you're doing, theoretically about 1.2 gig a second on those. The problem is the internet gets in the way. And even though Amazon has a massive internet backbone, Oracle has a massive internet backbone, what happens in between them is out of the control of both of those clouds.
Yeah.
Some days you would get 1 gigabit a second. Other days you get 100. Some days it just wouldn't work. And that unreliability was the problem, because what the end result of that was the developers wouldn't be able to work because they don't have data that was refreshed, so they can't work. So you lose a day's worth of development time. So the solution to all of that is to use Amazon's Direct Connect and Oracle's similar private connectivity construct connected together through Equinix. And that process meant that they had observability, stability, and consistency, and also control over that path. So they could do things if things weren't working. Whereas on the internet, there's really nothing you can do. If the internet's not working, who do you call? There's no internet person on the end of a phone. So if you think about that, that sort of example can be extrapolated to any number of other business outcomes that you have. The internet is a fine transport mechanism, but it was never meant for very specific types of workloads.
Yeah, great for searching Reddit and Facebook Marketplace for that next hot deal, because, we're all just searching for, I guess, like true value. And you talked about, it's accessible and it's cheap, but it's not reliable, and trying to find like all edges of that triangle is true, whether you're, buying a lawnmower or you're buying private interconnection. Yep.
Fast, cheap, and reliable, pick two. If you're doing a project, time, cost, and money, pick two. This is always an optimization thing. And that's why I kind of use that phrase as the internet's good enough until it's not. I'm not telling you not to use the internet. Yeah. Because it's a cheap, and it's easy to access, and it's ubiquitous. And things like SD-WAN provide you at least some level of observability and control. But you have to realize that the underlying architecture is public and you don't have control over what happens. So even though you can monitor either end of it, what happens in the middle is not for you. And there's been some famous examples of that, with traffic being routed through China's firewalls accidentally because people in Malaysia have misconfigured internet routers. That sort of stuff is problematic if what you're looking for is a reliable and consistent user experience for high-value business applications. But if what you're doing is other things, that's perfectly fine.
Yeah. And, have you been talking with folks that are in the process of making a decision about, trying to go the private interconnection route for a specific project, like the one you laid out, with having workloads in both Oracle and AWS? What's that biggest driver? Is it security, cost, performance, or something else?
Often it becomes quite a specific thing to what the company is trying to achieve. One of the biggest conversations that I get into a lot is that people equate SD-WAN with internet only. So I'm going to implement SD-WAN, I'm just going to buy internet circuits. And the point that you kind of get to is that's fine for the last mile, but often not good for your backbone.
Right.
Because the outcomes that you want from the last mile are not the same as the outcomes that you want from your backbone. And SD-WAN is not incompatible with MPLS, with leased line, with T1, with things like our Equinix fabric. You can use all of those underlying transport mechanisms and have SD-WAN as the control plane over the top. And this is probably one of the key points that I make with people, is that don't throw away private connectivity just because you think SD-WAN is a replacement for it. It's not. It's just a technology that's an overlay.
Yeah, I mean, I feel like when I was talking to salespeople, they were trying to just tout SD-WAN. It's just like, oh yeah, it's just like another VPN.
I think the biggest thing is that, you know, architecture is a series of choices, and there is no single solution to any given problem. And efficient architecture takes that into account and helps you build the most robust way to deliver packets that you can over whatever transport mechanism that you need for the outcome that you're after. And so a lot of the customers that we talk to look at engineering backbones using either our network service providers inside our buildings through private interconnection, or using things like our Equinix fabric to create our backbone, and then taking that traffic and dropping it out inside local loop providers for the last mile. And that kind of structure is repeated quite a lot with most of our customers. And the private side of that interconnection means observability, it means reliability, it means consistency, things that you just can't get from a public internet service.
Yeah, I tried to forget my days working with T1s and MPLS and calling in and asking somebody if they can, can you loop the smart jack for me? And we're still having issues with that circuit. And nowadays, what do we got? We got people trying to vibe code their way through network architecture, and who knows what kind of messes they're going to be creating with this whole thing.
Yeah, I mean, intent-based networking is the next biggest thing. I feel like people applying large language models to a specific network outcome is going to result in some interesting outcomes. Large language models are to a degree a 1 + 1 = mostly 2 outcome. If you're producing an essay about penguins, there's plenty of different ways you can create a coherent essay about penguins. But there's very few ways that you can create a coherent Cisco Catalyst 8K config that exactly routes this traffic from point A to point B with these BGP keys. So mileage, I think, may vary in that piece, but where I think large language models, and particularly generative AI, will shine in that network space is, time to resolution kind of discussions. If you've got multiple systems in a very complex environment, then using large language models to use tooling that would otherwise be used by network engineers to produce observability and surface insights and get you faster to a resolution time because of that, that's certainly a really good use case for that sort of network operation. In fact, we do that with some of our internal network tooling here with AI assistants that are doing that sort of observability work.
Yeah, that kind of stuff is honestly like really great, and where I see it continuing to expand. Like observability, helping with alerting, like it can be of a massive help there. And I think the next place for us to go obviously is getting into starting to dip our toes in the water a little bit about AI and AI infrastructure. Over here at Telnyx, we're seeing that having low latency global interconnection, it's kind of the backbone for our real-time agents, especially since we, sort of built the network first. Where do you see Equinix's fabric, intersecting with companies like Telnyx and, how its ability to support those type of experiences for like ultra low latency voice agents?
So I think for a large industry perspective, what we're starting to see is agentic AI. So your large language model is using tooling, not necessarily other LLMs as well, other tooling that is built on more traditional APIs or algorithmic outcomes. And we're starting to want that inserted in real time. So where previously we had algorithmic systems that were doing analysis after the fact.
Mm-hmm.
Starting to say, I want to put those systems right up close to the user where the transaction is happening in order to take action during the transaction. So your point around voice agents is if someone's having that conversation with that voice agent and that voice agent is calling some tooling, then you want consistency in that experience. People are generally okay with something taking 2 or 3 seconds. What they're not okay with is sometimes it being 1 second and other times it being 20.
Yes.
That just injects a whole bunch of frustration in the process because the variability is what kills people's experience. And so I think what you're starting to see is people wanting to deploy inference engines more distributed. So I want to add multiple places around the world in order to supply decision-making systems to my customers. So think of something like fraud detection is a really good example of this. Do you want to make a decision on whether that transaction is fraudulent when it gets all the way back to your central system?
Mm-hmm.
Or do you want to make that decision at the point of sale or somewhere in between that so that you can, where do you want to prevent the fraud? Up here is probably too late because at the end where it's all stored in the system, that transaction's already happened. Now you've got to go through the whole process of unwinding that. Whereas if you could push it out as close to the point of sale terminal as you could, then there's potential there that you could get in the middle of the transaction and stop it before it settles, in which case you don't have to unwind anything, right?
Right.
So that level of proximity and latency, as we start to see agents being deployed, is going to be more and more important.
Yeah, I agree. You know, you mentioned we're talking initially starting to talk about like all the submarine cables, and it's like, you know, that data's got to backhaul its way on that undersea cable from Sydney to US West, from there to who knows, AWS or whatever, and then back again. You know, that's going to add a considerable amount of time, no matter how fast the LLM is. It's, you know,
well, light in a cable only goes so fast. Physics is very specific about the speed of light in a non-vacuum. So, you know, no matter what happens, you still got to go halfway around the world and come back again. There's a good 200 milliseconds worth of latency injected in that process, let alone any sort of higher stack latency involved in application processing or large language model processing that's added on top of that 200 milliseconds. So your baseline is going to always be that. Hence why, you know, places like Equinix exist, because people want to move workloads proximate to where the users are to increase the user experience. And the faster the more you can do that, the faster the transaction will be, the better it is for the users, and thus the more transactions you can make, therefore the more money you can make, and so on down the economic stack.
that is the key to all of it. And yes, you can't beat physics. Sorry, folks. You know, you have a question about it, go throw a apple up in the air and then let it hit you on the head.
I am very happy that physics continues to work every day.
Yeah, we get to stay on this planet, right? Or not floating off into space somewhere.
Yeah, it would be a very awkward life if you had to tether yourself to the Earth, because forces didn't work that way anymore. But there you go.
Let's hop into some GPU talk. Right, talk about some building some of this AI infrastructure that we're going to interconnect over optical networks. You know, GPUs is the hottest word. Everyone's talking about AMD and NVIDIA and TSMC. You know, you've emphasized that AI infrastructure isn't just about compute. So, you know, like from your vantage point, like what's the biggest overlooked elements of this? Is it like power? Is it cooling? Is it interconnection?
I think probably the most overlooked thing in AI infrastructure is data. You know, AI is an engine and data is the fuel. And without the right fuel that's been tuned properly for the engine that you're putting it into, you're going to have a pretty bad time with your AI systems. The model that's been trained, how it was trained, the data that was trained on, the data you have access to, and the data you're generating are all key important parts of that continuum. When we talk about physical infrastructure, you know, AI, particularly private AI stacks, which are starting to be deployed by a lot of large enterprises, for consistency and user experience reasons. I mean, we're talking about some seriously heavy infrastructure. We're talking about physics just before. The racks that are going in now for some of these big AI deployments are 120 kilowatts. And they're now talking about, getting up to 600 kilowatts or more per rack. If you look at some of NVIDIA's keynotes at their last talk, they're really talking about some serious kit. And that has some on-flow effects, because you put that much power in the front side, physics say you're going to generate this much heat at the backside. And being able to cool that as well is problematic. So generating the power, distributing that power, consuming it in a data center, then cooling that infrastructure appropriately means we need to go to liquid cooling. And so Equinix has a fleet of data centers around the world, and we have a large number of these now that are enabled for liquid cooling. Customers who are trying to deploy this sort of private AI infrastructure. And that is certainly a trend that's happening in the industry, but it's not just large language models. We forget that artificial intelligence is a broad spectrum of things, from machine learning and deep learning. We're doing HPC for a long while, doing Z-series, IBM Z-series mainframes, which are also liquid cooled. So, it's not, this is not technology that suddenly popped out of nowhere. So it's an interesting time to be alive in the data center industry, at least, as people start to put what is very heavy infrastructure in us. The other thing to pay attention to is when we talk about liquid cooling, so one thing that people don't think about much is that when I say I'm going to liquid cool NVIDIA's GB200 rack, that's only typically about 30 to 40% of the IT load. The rest of the IT load in there is still air cooled, because it doesn't have liquid cooling enabled direct to the chip. So some of the newer designs they're trying to do, like, let's cool everything liquid, in the interests of removing fans completely from the chassis, which consumes power.
Yeah.
Do that. So there's a lot of things that are happening very rapidly in infrastructure design right now that's affecting how we are reacting to that.
And then it won't sound like you're walking into a jet engine every time you walk into a data center. There's a lot more fanless infrastructure.
Yeah, it's an interesting thing to go and actually see some of this stuff in operation, where, if we go back to, I've been in this industry for a long time, and when we first started doing blade infrastructure, you get a wall of those. There's some render farms for some large film companies. You walk behind the render farm and it was basically just blowing air at you as fast as it possibly could, flattened against the back of it. And, the new modern stuff that's liquid cool, that certainly doesn't have that level of exhaust happening.
Yeah, and there's a lot of talk about that with like the liquid cooling. People, kind of like some NIMBYism with not wanting data centers near their homes, and they talk about utilizing freshwater resources. I mean, so when they're talking about liquid cooling, is it truly using just water? Is it like coolant? As we're talking about it being an engine and using fuel. Is this the coolant for the engine?
So sustainability is an important conversation in the data center industry, both from a electric generation perspective and renewable energy sources, and also from other environmental impacts like localized water use and other things. So to a large degree, we as Equinix have a very significant sustainability program looking towards 2040 to reach net zero GHG emissions across our value chain.
Wow. And
water cooling does present some challenges around there, but where possible, we're using renewable sources for that. And a lot of this stuff is used off existing data center chilled water that's in the facility. So it doesn't really increase to a large degree the work that's being done by that data center. But I think there's also a lot of challenges for the AI industry in general as they start to think about what less brute force approaches to AI and reducing the amount of infrastructure that's required to get the same outcome. So as we move into more mature cycles of this, I would expect that we see custom ASICs and other things that will start to reduce or at least stabilize power requirements.
Yeah, and there's constantly new evolutions in the power generation space as well. So we'll sort of see, like, as that evolves at the same time, we could have sort of a moment where the two coalesce kind of perfectly, as disparate teams are trying to work towards like a solution.
Yeah. So we in Silicon Valley have a partnership with Bloom Energy,
Mhm.
who fuel cell, chemical fuel cell power generation. So that's powering some of our facilities in the Silicon Valley area. So we're trying to innovate as fast as we can with partners for looking at alternative sources rather than pollution generating energy.
Yeah, other means to cool spaces. I mean, I'm over here in Chicago. In the wintertime, just open up some windows. I mean,
Well, that in the environment and environmental cooling is certainly an interesting topic. Chicago's weather can be adverse in completely the opposite direction, where it's way too cold, and that presents its own challenges as well. We need to find a place that's perfectly 22 degrees Celsius, or in Fahrenheit these days, what's that, 44, 76-ish, just 76 completely all the time. That would make life easy for everyone. But unfortunately, the world doesn't work like that.
No, it does not. And since we understand the cooling bottlenecks pretty well, and the power, is there anything else that sort of comes to mind, maybe from like a networking perspective, when we're working with AI workloads versus like traditional data flows for network design?
Yeah, so I think, as we pointed out before, if data is the fuel to the AI engine, getting the fuel to the data through fuel pipelines is an important part of what you need to think about. To a large degree, people are just asking for more and more and more and more bandwidth.
Mm-hmm.
The customer asked for 1.2 terabits of bandwidth between cities in order to deliver data to an AI system.
Okay.
That's a significant amount of traffic, and certainly not what we're used to in delivering on Ethernet. If you look at the innovation that NVIDIA has in some of its switching, where they're looking at direct RDMA access from the GPU and the CPU, but also extending that between GPUs in a pod, and then extending that between pods. And now they've recently announced that they're doing looking at metro deployment of that sort of technology.
Oh, wow.
Really an iteration again above the Ethernet standards to try to deliver data in a fashion that AI needs as fast as you possibly can. Because to a large degree, all of these systems are trying to work in synchronization for parallel processing. And if you can't get more of them in a pod, you need to get more pods. If you can't get more pods in a data center, you need to get more data centers. And so this continual process in the chase of more AI cycles are only going to make that harder to achieve.
So how many like fiber links are they trying to bond together to get to 1.4 terabits?
So you'd be bonding 400 gig ones or 400 gig circuits together in order to try and deliver that outcome. The thing with AI data transfer is it's also incredibly bursty. So I want 1.2 terabits of traffic for about 3 days.
Yeah.
And then I don't want any of it. And this is diametrically opposed to the way in which we've traditionally deployed networks in the past. In the past, you would go, I'm going to commit to 300 gig of bandwidth for a month. And you just wait for 1.2 terabits to go across it. But now I know it's absolutely not the case. I want the 1.2 terabits yesterday. In fact, if you had a time machine on your network and could deliver it yesterday, I'd pay you even more money. But ultimately that changes what's happening now. Is incredibly bursty workloads, and then nothing, and then incredibly bursty again.
Yeah, I like that I like the fuel analogy, because like the data, like it is as volatile as fuel. You need to protect it. As we all know, there's so many different regulations that we have to abide by when it comes to data handling. it is the lifeblood of your AI workloads. If you have bad data, just like bad gas, the engine's not going to run. So, I mean, it's imperatively important that your data is in good shape. And also dealing with this burstiness, the same thing. I mean, you flood an engine if you're bursty all the time.
Yep. And so I think when we start to talk to customers about this a lot, it's about where you're putting your data and how you're storing it, how you're curating it, how you're keeping it fresh, making sure that it's fed appropriately to the systems that need it. Are you paying attention to data sovereignty issues around regulations in the particular environment it needs to be stored? So for a lot of customers, what you're starting to see is like I'll pull EMEA data in EMEA, American data in America, and APAC data across a couple of different jurisdictions because of the distributed nature of the Asia Pacific market. And that process then means that you're getting a bit of a data problem where you start to sprawl that data out. So managing and collating that becomes the issue as well. And that's, I think, the biggest challenge in AI these days is making sure that you have the right data at the right time and the right consistency for the AI system to make a decision, or be a voice agent that's making decisions for customers.
Yeah, that is exactly some of the things that we're seeing over here, because we have taken that approach with, having our AI infrastructure, in the US, in EMEA. I think shortly here we will have some infra deployed in Australia as well. And we're not in the data business. We're in the business of like transmitting your data, right? So you're bringing your data to us for your voice agents, and you face all of these things where okay, yeah, we're still going to try to use this data store that's in SV1. No, you need to bring this data over to one of the Telnyx pops, so that again, we're not really able to provide value to you if you're going to try to keep your data segregated all the way over on the west coast of the US for workloads that are occurring in Australia.
Yeah, so it's an interesting conversation to have with customers when you talk to them about AI and they're going, oh, we just need to implement some GPUs.
Yeah.
And the first question I ask them is, where's your data? And have you gone and curated it? Because if you haven't, it's probably going to not matter how many GPUs you buy and put in our data center, you're not going to have a good time.
Yeah, I mean, that is like the big issue, especially dealing with some executives that aren't necessarily trained or spent the time to understand. There's like, oh, we need to use AI, guys. We should be using AI yesterday, and so they task people to go out there and find solutions for them, and then they're sort of the blind leading the blind, as the saying goes.
Yeah.
But I want to make sure I'm super mindful of your time, because this has been like a great conversation. So in closing, let's sort of zoom out a little bit. I'm a big fan of this method of sort of looking down where you're sitting at right now and just kind of zooming out and zooming out and zooming out. So you see your city and your state and your country and the globe and far out into space. So if we were to look maybe 3 to 5 years out, like where do you think we're going to see the biggest shift, in global interconnection and in AI infra?
So I think the distributed AI and distributed inferencing is probably the biggest shift we're going to start to see. Model training and the ability to build new foundational models, I think, will remain the capability of a few select people.
Mm-hmm.
But using those agents to augment human activity, not necessarily to replace it, but certainly to take some of the drudgery from the work that we do, is certainly a great use case for that. And that distributed nature of it, where those agents are living out close to where the users are and assisting them with that removal of drudgery, that's probably the future of things. To a large degree, I think the Sun Microsystem said it in the early 80s that the network is the computer.
Yeah.
And now with agentic AI and our use case of going talking to ChatGPT or Copilot or Claude, that network is really becoming the fundamental part of how we interact with that computer.
No, it's so true. So true. And your sort of last little bit here, if you had to give one piece of advice for enterprises to prepare for our AI-driven future? What's it going to be?
Make sure you think about people first, how people are going to use it, what that means for how they're going to use it, and what that means for your upcoming business processes. And once you've done that and you put some governance in place around that, including the risks associated with it, go and have a look at your data. Where is it? What do you got access to? What are you going to need access to before you start thinking about anything else?
Great advice. And I think it holds true for sort of everything in technology. Like those statements aren't necessarily like brand new. Like this is what we've always had to be concerned with as we grow with technology and as it continues to advance.
Yep.
So Nicholas, hey, you're a legend. Thank you so much for taking the time. Hopefully we get to chat soon. I think last time I talked to you, you're going to hook me up with someone that knows all about all the optical networks, and I still might take you up on that.
I will do. Thanks for letting me chat on your podcast. Hopefully that's been useful. We'll talk another time.
Great. Thanks, Nicholas. Have a great night. Ciao.
Thanks. See ya.